few more formulas of inverse trigonometric, and from there we will be discussing the problems, how we can approach the problems of mains and advanced. And please revise the earlier lectures. The basic concepts I've already explained in those 3 lectures. So the first formula we have already studied, the tan inverse of x plus tan inverse of y. This tan inverse of x plus y upon 1 minus xy when x into y's value is less than 1. When x into y is greater than 1 and x is greater than 0, y is greater than 0, in that case we add pi. When x is less than 0, y is less than 0, x, y is greater than 1, we subtract pi there. Now similarly, the other formula of tan inverse of x minus tan inverse of y, we can develop here. If you remember the only one formula of tan inverse of x plus tan inverse of y completely, you can solve literally any problem of the inverse trigonometric function, because rest we can develop and we can convert in our forms. Let's see. If I take the second one, the tan inverse of x minus tan inverse of y formula. See, we can obtain this formula of tan inverse of x minus y upon 1 plus xy. That's quite easy to understand. See, already we have the formula of this tan inverse of x plus tan inverse of y. So I'll tell you what your approach should be. The tan inverse of x plus, now in that case y I am subtracting by minus y, and this is equals to tan inverse of x minus y upon 1 plus xy. So here I have substituted this y as a minus y. And we know that tan inverse of minus x is minus tan inverse of x. As we know that tan inverse x is an odd function, because we can write tan inverse of minus x is equals to minus tan inverse of x. Why? Because it is an odd function. So here I have this substituted the value of y as a minus of y there. Now you see here the x into y is less than 1. So when I'm changing the sign of y, automatically the x into y's value will be greater than minus 1. So this formula, as you are using directly for the tan inverse of x plus tan inverse of y, when x into y is less than 1, the same formula for the tan inverse of x minus tan inverse of y, you can use directly when x into y is greater than minus 1. And what happens when x into y is less than minus 1? So there are two possibilities are there. You can see the first possibility you can derive here. From here you can see the second. As x is greater than 0, y is greater than 0 and product is greater than 1 when I'm solving tan inverse of x plus tan inverse of y. Now as I have replaced this y value by minus of y, what has happened? X into y has become less than minus 1, you can see here. And this y was greater than 0, and when I am replacing y by minus y, so obviously y will be less than 0. So in that case, I can use the formula directly there, but what will happen here? I was adding pi in tan inverse of x plus tan inverse of y. So in tan inverse of x minus tan inverse of y, again I'll add pi. And when x is less than 0, y is less than 0, in tan inverse of x plus tan inverse of y, x into y was greater than 1, we subtracted pi there. And you can see there, x is still less than 0, but as y have replaced by minus y, so y's value has become greater than 0. But their product is still less than minus 1. In this case, we subtracted pi. Same here, we will subtract pi. So this formula you can now convert, that you can write directly when x into y is greater than minus 1. Here the sign has become minus now, and it is plus. And when x into y is less than minus 1, x is greater than 0, but y is less than 0. In that case, this side I'll add pi. Means you'll write pi plus tan inverse of x minus y upon 1 plus xy. When x is less than 0 and y was less than 0, you are subtracting pi in tan inverse of x plus tan inverse of y. So now when we have written the y's value as a minus y, so in that case now the y will be greater than 0, but x into y is less than minus 1, still it is, and in that case we'll subtract pi. So pi minus pi plus tan inverse of x minus y upon 1 plus xy. So if this formula you know completely, you can solve any problem related to the inverse trigonometric function, because if anything is given in the form of a sine inverse of x, see, you have to remember this formula only. And you see that how I have derived this formula by replacing the y value equals to minus y. Same formula you can derive also. For more formulas you can, I'll just tell you further how we can use this. So now let's say I'm replacing y is equals to x. So what will happen here? You see, in that case, as you have tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus xy when x into y is less than 1. Now if I'm replacing y as x, so obviously x square's value is less than 1. So that means x belongs to minus 1 to plus 1. So, and this y has become x, so it will become 2 tan inverse of x is equals to tan inverse of x plus y upon 1 minus xy. And see this as, this y as a place by x, so it will become 2x divided by 1 minus x square. And see, when x into y is greater than 1, means x square's value is greater than 1. And when x is positive, in that case what you will do, you will add pi. Means 2 tan inverse of x will become pi plus tan inverse of 2x divided by 1 minus x square when x is greater than 0 and x square is also greater than 1. And when x is negative, obviously y is also negative, so means both x is negative there, and but still you have x square's value is greater than 1. In that case 2 tan inverse of x can be written as a minus pi plus tan inverse of 2x divided by 1 minus x square. So this is what when you add pi, and this is what when you subtract pi there. Similarly, you can derive the formulas for 3 tan inverse of x also by converting as a 2 tan inverse of x plus tan inverse of x. So this I'm just leaving to yourself that you just attempt this, and which I'll be explaining in the next lecture. So any formula you can convert in like this. Say anywhere it is, somewhere you have written sine inverse of some k1 plus cos inverse of k2, like this, something you have to prove like this. So I will advise you to convert those sine inverse and cos inverse in tan inverse, because you know, see, the domain of sine inverse of x is from minus 1 to plus 1. So any value which I write there, obviously I can convert in the tan inverse, because what happens, the value, whichever value you are writing there, that will obviously some value of tan inverse of x will be there. For that you can write that some sine inverse of k1 has to be some tan inverse of some k1 dash. because this domain is all real numbers. Okay, so you know the methods I have already explained in the earlier lecture. So let's say anywhere it is, you have to find the sine inverse of 2 by 5 plus cos inverse of 3 by 8, like that. So what you do, you just form a triangle and get the values of tan inverse. That's quite easy to understand. One example I'll tell you how you can solve it. So this is sine inverse of 2 by 5. So this is 5, this is 2. You can find this under root of 25 minus 4 under root of 21 you will get there. So if this angle is theta, so sine theta's value is given 2 by 5. So tan theta value you will get 2 by under root of 21. So theta is tan inverse of 2 by under root of 21. This is some angle is represented. So it's up to us whether I want to write that angle in the form of a sine inverse or I want to write in the form of a tan inverse. So I can write this as a tan inverse of 2 by root 21 also. Similarly for 3 by 8, we can draw a triangle there. This is 8, this is 3, this angle I have taken as a theta. So that is 64, and 64 minus 9 is 55. So square root of 55 will get. So in that case we can write this as a tan inverse of under root of 55 by 3. And thereby mere checking into whether x into y is greater than 1, both are positive, or x into y is less than 1. Accordingly we can add pi or subtract pi and we can get the result. So it's advisable to convert all these sine inverse, cos inverse, tan inverse, sec inverse, cosec inverse, cot inverse, all these you just try to get in tan inverse, and then you apply the formula of tan inverse of x plus tan inverse of y, or it is tan inverse of x minus tan inverse of y. You can convert the tan inverse of x minus tan inverse of y in tan inverse of x plus tan inverse of y by substituting the y as a minus of y. So that's quite easy. So I'll advise you just to remember these three formulas of the tan inverse of x plus tan inverse of y thoroughly. Now I'll take an example. Let's say we have a one triangle given. And this triangle is ABC. Angle A is tan inverse of 2. Angle B is tan inverse of 3. And you're asked what is the angle C. So we know angle A plus angle B plus angle C is equals to pi. So we can write that the tan inverse of 2 plus tan inverse of 3 is equals to pi minus, we can write tan inverse of 2 plus tan inverse of 3 is equals to angle C. So there now we'll use the formula of tan inverse of x plus tan inverse of y. So here you can see that x into y, the product I'm getting more than 1. So when product we get more than 1 and x and y both are positive, in that case what we do, we add pi. So I'll write pi plus tan inverse of 2 plus 3, which is 5, upon 1 minus 2 into 3, which is minus 5. I have substituted the value of tan inverse of x plus y upon 1 minus xy, where x value is 2 and y is 3. So that is tan inverse of 5 upon minus 5. So we get pi plus tan inverse of minus 1. Now I'll substitute pi minus tan inverse of minus 1. So you see pi cancel, minus tan inverse of minus 1, you will get minus tan inverse of minus 1. and that can be written as a tan inverse of 1 because it is an odd function. So tan inverse of 1 whose tan theta is 145 degree. So angle C is equals to pi by 4. So in any other form, even if it is given in the form of a sine inverse, this angle is given, this angle is given in the form of a sec inverse. So it's advisable to convert in tan inverse, and after converting in tan inverse, you have the understanding when you can write the formula directly, tan inverse of x plus y upon 1 minus xy. And when you add pi and when you subtract pi, this idea you already have. So one more example I'll take now. That is sine inverse of cot of sine inverse under root of 2 minus under root 3 divided by 4 and plus cos inverse of root 12 divided by 4 plus sec inverse of root 2. So here you can see that sine inverse of 2 minus root 3 upon 4 and plus cos inverse of root 12 by 4. So first what we can simplify this root 12 by 4 and we can write this as a directly cos inverse of this is root 3 by 2 because 12 you can write 2 root 3 there and plus sec inverse of root 2. So cos inverse of root 3 we directly know this is a 30 degree and so we can write this as a pi by 6 and sec inverse root 2's value we know it's a 45 degree. So this is pi by 4. So now we have to convert this sine inverse of 2 minus root 3 divided by 4. So I'm now, see, I'll solve it here some. See, 2 minus root 3 by 4, we can write this as a root 3 sine inverse of under root of 2 minus root 3 divided by 4. So this we can write sine inverse of root 3 minus 1 divided by 2 root 2. 1, 2 we have multiplied in the numerator and then you can write, I'll just explain you, that is 4 minus 2 root 3 we can write and denominator I can write. I'm just solving this part only so that you can understand. I can write like this by multiplying 2 in the both numerator and denominator and further 4 can be written as a 3 plus 1 minus 2 root 3 divided by 8. So you can see this is root 3's square and this is 1 square minus 2 root 3. So I hope it is clear now. So root 3 minus 1 upon 2 root 2 and we know this is a value of this sine inverse. This is, if you remember, this is a value of this 2 root 3 means you can write just as a root 3 upon 2 root 2 minus 1 upon 2 root 2 and that you can write 1 upon root 2 into root 3 by 2 minus 1 upon 2 into 1 by root 2. So you will automatically see that will become 45 degree because 1 by root 2 is 45 degree in this case and this is 60 degree and this is 60 for the cos and this is for 45. So that can be written as a 15 degree. So total value I'll get, this is 15 degrees. So I'll get sine inverse of cot of 15 degree plus 30 degree plus 45 degree. So if we simplify, I'll get 90 degree and cot 90's value is 0. So sine inverse of 0, the answer is 0.